let's finish our discussion of the things about Ruby that sort of make it different from other languages. We already talked about blocks and collection idioms and the pervasive use of anonymous lambdas and each. So there's a little more flavored idioms that are similar to those. And probably the most important one for really understanding the Ruby philosophy as a language is duck typing. So we mentioned this earlier, that even though Ruby is object-oriented and you can define classes and do all of the usual object-oriented things, most of the time, the class of an object is not what's really important about it. What's important is what methods does the object respond to? What is it able to do? And today we're going to look at what are some specific mechanisms that take advantage of that to encourage productivity through reuse, which is one of the 4 productivity mechanisms we sort of laid out when we did the blueprint for the class. The main mechanism that we're going to look at is called duck typing. And in case you've never heard this somewhat whimsical term, there's an expression, at least in American English, that if something looks like a duck, walks like a duck, and quacks like a duck, you might as well just call it a duck. So duck typing is the idea that if you have an object and that object responds to some of the same methods as some other kind of thing, you might as well call it that other kind of thing. You might as well say it's a duck. And if you're familiar with interfaces in Java, this is a similar concept, but I actually think that the Ruby version of this is easier to use. So when we looked at collection idioms, one of the ones that we looked at, for example, was sorting a collection. Here's a couple of different arrays, but they have different types of elements, and yet sort just seems to magically work on both of them. And here's a third kind of collection. IO read lines actually will, one at a time, give you back the lines of a file, and we can just say, sort the lines of the file. So obviously, well, I guess not obviously, this thing is not an array, but sort still works on it. So what is the kind of reuse that enables something like this generic functionality of sorting to be reused across obviously different classes? And to understand the mechanism that Ruby uses for this, it's called modules. A module is basically a collection of methods under its own namespace, but it's not a class. So if something is a class, you can create an instance of that class and you can do things on that instance. A module is just a collection of methods, but you can't instantiate it. So what do you use it for? Well, a really simple usage is it's just plain old a namespace. So for example, there's a math namespace that defines a sine function, and it also defines a constant for pi and things like that. But the much more interesting use of a module is to mix its methods into a class, which means that the class basically gains the ability to have those methods, but without those methods being explicitly defined in the class itself. So for example, if we go back to our bank account class, which we're going to see a few times today, and we say include some module, that basically means that any of the methods defined in that module now become available to instances of the class. They're not methods that are defined within the class, and that means that there's got to be some expectation of what is it that makes the class able to sort of absorb that module or include that module. So for example, now when I call a method on an instance of that class, if that method exists because it was defined as part of the class, then it will get called. But if it doesn't exist in the class, any modules that were included in the class are searched next. So that's why this is a way to essentially add new behaviors to a class, but without expanding sort of the footprint of what the class does. And I'll show you some examples in just a moment here. Enumerable. This is the example that is pervasive throughout Ruby. Enumerable is a module that is part of the Ruby standard library in the same way that, file IO is a collection of methods that are part of the Ruby standard library. And the enumerable module is mixed into most collection classes. That means most collection classes absorb the ability to do the things that enumerable does. So what are those things? Well, the important aspect here is that the enumerable module makes an assumption that if you're mixing it into a class, that class has a method on instances that can respond to each. In other words, an instance of that class is something that can enumerate itself and give back one member of the collection at a time. Whether the collection's an array or it's a hash or a list of files or a random number generator, doesn't matter. As long as you can call each on an instance of the class, the enumerable module now provides a whole bunch of other behaviors that are sort of trivially enabled as long as you can call each on the class. So for example, you can ask if something is true of all or true of any of the aspects of the class. How do you do that? You just basically call each on every one of them and keep track of the results. You can do things like find. Give me all the members of the class that match a certain criterion. You can say partition. Here's a predicate. Give me back two collections where in one of them the predicate was false on all of the elements, and in the other one it was true on all of the elements. And with about 10 seconds of thinking, you can figure out that as long as you can enumerate each member of the class, you can implement all of these other things sort of generically. There's another module, comparable, that assumes that the target object responds to spaceship operator. The spaceship is this sort of less than, equal, greater than, and it's an operator that returns -1, 0, or 1, depending on whether the thing being compared against is less than, equal to, or greater than the target. And again, for one thing, if you know that instances of a class respond to spaceship operator, then trivially, you can make them respond to less than or equal to. You can ask if something is between two values. So comparable, basically, given that your class responds to spaceship, you get all the other behaviors and a whole bunch of additional ones as well. Enumerable is the module that provides sort. So sort just assumes that the elements of the collection respond to the spaceship operator. By the way, when I say they make these assumptions, this is not something where you can sort of look at a formal interface definition and figure it out from looking at the code. This is what you figure out from reading the documentation. If you read the documentation for enumerable, it basically says, in order to mix enumerable into your class has to have an instance method each. It has to have a way of responding to that on members of the class. So let's put all these things together. When I see a line like io.readlines, and as I've told you, readlines is a standard library function that one at a time will give you back each line of a file. If we call sort on that, there's actually two assumptions that are being made here. One of them is that whatever the thing is returned by io readlines, that thing responds to each. So I can call each on it, and every time I call each, I will get back the next line in the file. How the readlines function does that is none of my business, right? And in addition to that, the things being returned by each all respond to the spaceship operator. Now, in this particular example, usually the lines of a file are going to be returned as strings. So the effective assumption we're making is that the string class has an instance method spaceship, which will compare one string against another and tell you -1, 0, or 1, depending on whether the first string is less than, equal to, or greater than the second string. What does greater than or less than mean for strings? It means one thing for ASCII, it means something else for Unicode. But the whole point is it doesn't matter. So this is why this kind of behavioral reuse is so valuable. It's very abstract, saying as long as the target collection implements each, and as long as the elements of that collection implement spaceship operator, it doesn't matter what the classes of those things are. It only matters what the behaviors are. So that's kind of, this is sort of the most concrete example I can think of when we say class doesn't really matter so much in Ruby, which makes Ruby sound like a socialist paradise or something. But what matters is what the things respond to. And the language you'll sometimes hear Ruby programmers use is they'll say, oh, that class quacks like an enumerable. What that means is you can essentially make all of the assumptions about it that enumerable would make. And you can treat the class as any other thing that could enumerate elements of itself, right? So sometimes we'll say when a class quacks like a something, it means for all practical purposes, in addition to whatever all else that class does, you can treat it as that other something. Pretty powerful assumption. So let's put this into use in our simple example of comparing bank accounts. You can imagine it's not unreasonable that you might want a way to say, is one account greater than another? If you wanted to sort accounts, I guess the most obvious criterion would be which one has the greater balance. That one is larger than the other one. So given what we've learned so far, all that means is the bank account class has to define spaceship operator in such a way that one account can compare itself to another. Okay, we're going to decide that for our example, what that means is balance is being compared against the other one's balance. Now, in our specific example, we just care about spaceship because if we want to do things like sorting bank accounts, sort just relies on spaceship operator being defined. If we wanted to also be able to compare them directly, like if we wanted to write if account A is less than account B, then we also have to define things like less than, equal to, greater than, and so on. And the easiest way to do that, frankly, is just mix in comparable, which does it for us. And it also gives us between and a bunch of other things. So in our bank account class, we can optionally include comparable, but if all we care about is sorting, we don't actually have to. We'll go back to doing an example showing @accessor, but the balance is the only thing we care about in this bank account. And now we're just going to define an instance method spaceship operator, which means comparing yourself to the other account. All we're doing is self-balance being compared against other account balance. And sometimes the first time someone sees this, if you're new to Ruby, you'd say, wait a minute, why isn't this infinite recursion? And of course, the answer in this case is because spaceship operator in this example is being called on self.balance. And what's self.balance? Well, presumably it's a number, right? It represents the account balance. So the instance method spaceship on bank accounts will end up using the instance method spaceship of numeric, but that's fine. Numeric has a well-defined spaceship operator, so there's actually no recursion happening here. These are two different methods in two different classes. They both just happen to be named spaceship operator. And now we can sort of say an account quacks like a numeric. So you can do things like compare them and say, is one equal to, less than? You can say, is one between another pair of accounts? So that's basically an example of duck typing. To give you an idea of the extent to which these kinds of things are used throughout Ruby and modules being used to extend the functionality of some of the basic classes, let me just walk you through a few examples of things that are not in the Ruby standard library, but they are in the standard bundle of utilities that comes with Rails. So when you write a Rails app using Ruby, these are some of the functions that you get. And this comes in the form of a part of Rails called the core extensions. And here's just a few examples of the ways that Rails extends numeric. Numeric is sort of the abstract class that represents all different kinds of numbers, integers, floats, big nums, and things like that. If I say 2.hours.ago, then basically I will get the current time with 2 hours subtracted from it as a time object. Why is that? Because Rails has caused numeric to mix in these extensions that define methods like hours whose receiver is a number. I can also say things like 1 megabyte and get back the number of bytes in a megabyte. Back in the time realm, I can say things like 1 day from now. All of these calculations, you could imagine straightforwardly how you would write them as methods. Like the logic of doing this is not difficult. But what I think is very elegant is the ability to extend numeric by mixing these things in. And you can see that in general, you wouldn't want to put all of this stuff into the numeric class, right? Because if you do that, in some sense, you're assuming that everybody who uses the numeric class is going to want to have that functionality. You're creating a lot of bloat in a place where you might not need that bloat. So the nice thing about modules is that you can sort of selectively mix in the behaviors you want, right? In a web app, things like manipulating times and dates are extremely common. So it makes sense that a framework like Rails, which is designed for web apps, gives you a bunch of packages that can be mixed into a module like numeric, and they give you those behaviors. But if you were writing, a scientific app, you probably don't have a use for things like fancy date and time conversions. And so there's no reason to mix that module in, and no reason certainly to have those methods be part of the core functionality of numeric. Right? So that's the basic distinction. Modules give you additional functionality that, under the right assumptions, can be mixed into any class on a sort of on-demand basis.